Hello, this is a demonstration of through-hole soldering. Through-hole soldering is the classic technique for attaching electronic components to a circuit board. It's still very much used today for cheaper boards and for where the complexities of surface mount or multi-layer boards aren't required. As with any soldering technique, the first thing to do is to ensure that the area that we're working in is clean. This particular board has come from a Commodore Amiga 500 computer, about 1989 vintage, and it's suffered a snapped coupling capacitor, which is attached here and here. First thing to do, use a little isopropyl alcohol and ensure that there is no dust or residue or anything that will interfere with the desoldering process. As the solder on this particular board is rather old, I will apply a little flux to the area. Flux is a compound made from a selection of sources, but which you will usually use to help the flow of the solder itself. Next, we will remove the old solder joints. To do this, I'm using a soldering iron. This one's fitted with a 1.6mm tip to ensure good connection with the solder joint and get rid of the heat, and also solder wick, which is a braid of copper wire with more flux inside it, which should cause the solder to stick once heat is applied. This is taking a little time because the solder joint is really rather old. My soldering iron was set to 325 degrees C. I'm going to up that a little bit to 350. And change angle. There, I can see that's coming off better now. If you can see, the joint is starting to clear out. We'll move on to the joint towards the back of the board. Which is flowing. believe we have removed all we can from this side of the board. Just ensure that nothing else wants to come out. Now I think we can move on to the top side of the board. Here's the top side of the board. The capacitor in question is this axial type, which is providing coupling for this chip, which is part of the memory array. We will attempt to remove the solder which has flowed through from the top part of the joint. Now with the help of some trusty tweezers, we'll apply the heat to the remaining solder. And the component is free. On this side we have the remaining leg, which used to connect to the old capacitor. We'll attempt to remove that. That's quite easy. That seems to be a little more willing. There we go. So we'll clean up the area again with a little more solder wick. A common alternative to solder wick or desoldering braid is the use of a solder sucker pump. They are a perfectly good way to do this and very generally well suited to through-hole soldering. They also have the advantage that they work for quite some time, whereas solder wick has to be regularly cut off and disposed of. Now, again, cleaning. There's old residue of flux here, isopropyl alcohol, and a scrub. Means that we have a clean working area again. Okay, as is sometimes customary with tiny pieces of component, it has exited and is now lying somewhere where these little bits of metal go. We know not where. Okay, so let's cause more old flux to appear. We don't want that in the working area. it is time to fit the new component. Placement component is a similar axial capacitor which we will place through the hole and into a similar position to its predecessor. We'll secure it by bending the legs, turning the board, and applying some new solder. I'm using flux cord solder, so I don't need to apply any further flux. What I shall do is tin the tip of my soldering iron, which means placing some new solder onto it to ensure it's conductive. As far as heat goes, and then we will place the soldering iron on one side of the component and solder on the other side. The joint should be as small as possible, it should be neat, and it should be shiny. Yeah, that should be sufficient to hold the component in place. We'll check the other side once more and see if we have had enough flow of solder into the work area. We have had one joint slightly more successful than the other. Some solder has come through and flowed nicely here. The other side, while there's nothing particularly wrong with it, it could do with just a touch more solder on this side. Just to ensure that there's connectivity all the way through. Okay, this side of the board is done. Of course, we will clean again. Finally, move to the far side of the board, remove the unnecessary length of component legs, one final clean, and we can inspect the joints as they've been finished, just to make sure that there is no problem, overflow of solder. And there we have it. A new capacitor for the latching chip on this Commodore Amiga 500 board. Thanks very much.